Welcome to my video. In this video we're going to look at a sorting algorithm for AQA's GCSE in computer science. The sorting algorithm we're going to look at is the bubble sort. The key stages of the bubble sort are: it compares each item with the item next to it, and if they're not in order it will swap them. The algorithm finishes when no more swaps need to be made. It takes the largest item and it bubbles it to the top of the list, and it takes the smallest item and it bubbles it to the start of the list. The bubble sort is very inefficient for large lists, but it's very easy to implement. This makes it a great choice for very small lists. I'm going to start off with what our intentions are. We intend on taking this data here, which is unsorted, and make it look like this, which is sorted. Now we're going to make the computer do that for us, and we're going to learn the algorithm for the bubble sort. The first thing it would do is it'd start out at item 1 in the list. In this case is 25. It would compare 25 to 17. 17 is less than 25, okay, so therefore they swap. It moves to 25 now, so it's moved up the list to it now here. It does 25 v 34. What do you think? Well, they don't swap because 34 is greater than 25. It now does 34 v 26. Well, 26 is less than 34, so they swap. 34 v 34, well, they're the same, so it just stay in the same place. 34 v 37, well, 34 is less than 37, so they don't switch. 37 v 25, well, 25 is less than 37, so you've got it, they switch. 37 v 28, well, 28 is less than 37, so they switch. 37 v 39, well, 37 is less than 39, so they don't switch. 39 v 20, well, 20 is less than 39, so in fact they do switch. So, why have we not completed? Because our intentions are to get the data into order, and it's still not in order. If we look here, the 20, although it's moved down the list slightly to here, it's still not in the correct order. It should be here somewhere, shouldn't it? So what you've actually done here is you've completed the first pass, and that's an important term. The first pass means that you've gone through the list once. So now we are going to start the second pass. So it goes right back to the start and it does the same again. Okay, 17 v 25, well, there's no switch there. 25 v 26, there's no switch there. 26 v 34, there's no switch there. 34 v 34, there's no switch there. 34 v 25, well, 25 is less, so it switches. 34 v 28, well, 28 is less, so it switches. 34 v 37, there's no switch. 37 v 20, well, 37 is greater than 20, so there's a switch. 37 v 39, well, they're already in order, so we don't switch. Now what do you think we've done here? So this is the end of the second pass. So now we would start the third pass because it's still not complete, is it? Can you see why it's still not complete? It's because, correct, it's not in order. Okay, so let's start the third pass. What I've done now is I've put them all next to each other. So this is the original data, the first pass and the second pass we've just done, and this is the third pass. So the reason I've done this is so you can see the colours, and you'll see, particularly with the 20, you'll see it bubble to the front of the list. Let's have a look then. 25 v 26, no swap. 26 v 34, no swap. 34 v 25, well, 34 is greater than 25, so they swap, as shown here. 34 v 28, well, 34 is greater than 28, so they swap. 34 v 34, no swap. 34 v 20, okay, well, 34 is greater than 20, so they switch. And you can see, look, already this bubbling pattern we're getting. 34 v 7, v 37, no swap. 37 v 39, no swap. And now we come down to here. Now I've just block filled this for quickness. 17 v 25, no swap. 25 v 26, no swap. 26 v 25. Well, 25 is less than 26, so we get a swap. 26 v 28. Well, 26 is less than 28, so there's no swap there. 34 v 28, no swap. Ooh, 34 v 20. Well, 20 is less than 34, so we get a swap. 34 v 34, so therefore no swap. 34 v 37, no swap. 37 v 39, no swap. And we come back round again to start the fifth pass. Now I've block filled it again. 17 v 25, no swap. 25 v 25, no swap. 25 v 26, no swap. So let's get to here then. 26 v 28, no swap. 28 v 20, well, 28 is greater than 20, so we've got a swap. 28 v 34, no swap. 34 v 34, no swap. 34 v 37, no swap. 37 v 39, no swap. So now we're on to here, block filled again. 17 v 25, no swap. 25 v 25, no swap. 25 v 26, no swap. and then we're here 26v20. Okay, so 26 is greater than 20, so we get a swap, and you can see this 20 look bubbling to the front. 26v28, no swap. 28v34, no swap. 34v34, no swap. 34v37, no swap. 37v39, no swap. Okay, so then we come round again to start the 7th pass. 17v25, no swap. 25v25, no swap. And then we've got 25v20, so 25 is in fact greater than 20, so they swap. 25v26, no swap. 26v28, no swap. 28v34, no swap. 34v34, no swap. 34v37, no swap. 37v39, no swap. And we come round to the 8th pass. 17v25, no swap. 25v20, well 25 is greater than 20, swap. 25v25, no swap. 25v26, no swap. 26v28, no swap. 28v34, no swap. 34v34, no swap. 34v37, no swap. 37v39, no swap. Again, I've just block filled some of those just for quickness, because at this point you've probably got it. And you can see if you look closely, look, that the 20, look, it bubbles right from the back of the list here all the way to nearly the front, because it's the second smallest in the list. Okay, if you look at something like the 26, look, you can see how the 26 begins to make progression. It ends up stopping here, and then if you look at the 28, look, you can see how it bubbled down the list, and then it found its point in the list. Okay, and you can see, look, where as the list starts to be in order, we end up with this almost tower build. Look, so it goes like that. Look. Okay, so you can see, look, the blocks of colour. Okay, I hope that helped. Right, we are now going to look at an exam question. So remember, a bubble sort, it takes data that looks like this and it gets it in this by comparing them one after the other, completing a number of passes until they're in order. Okay, exam question. It says, fill in the blank array to show the steps involved in applying the bubble sort algorithm to this array. 3, 5, 1, 4, 2. You need to only show the steps, the missing steps, where a change is applied. Now this is different to each pass. A change is literally where a swap takes place. So you show one swap per line. Okay. In a pass previously, you saw that 3 or 4 swaps could happen in one pass. Okay. This is literally going to show one swap per line. Okay. So let's go through that. So here we're starting here, aren't we? So this is original data. This is the outcome. So we start at 3 and we compare 3 to 5, and there's no swap there, so 3 just comes down. So now we are here. We now compare 5 to 1. Okay. And we know that 1's smaller, so 1 goes there and 5 moves to here. So we're now here. Okay, we have done our swap now for this row. Okay, so although in the past we're still here, you just fill them back in 4 and 2. So we're still technically there. Okay, so we come back round, just fill it back in 3, 1. Remember I said we were here because we're still midway through a pass. So we're on the 5. So we do 5v4. Now we know that 4 is less, so 4 goes there and the 5 moves to there. So we're now here. Okay, we're still in the first pass. Okay. And then because we're showing one pass per line, we've done a pass, so we just fill this in as 2. And we come back round. So we've got 3, 1 and 4, because we're still midway through a pass, so we're here. 5v2. Now we know that the 2 is less than the 5, so it goes there, and the 5 is there. Now you'll notice that we're here now. We're actually at the end of the first pass. Okay, so we move back to the start. Okay, so we're back to here. So we look at the 3v, the 1. Okay, because we're back here. 3v1, well 1's less than 3, so the 1 goes there, and the 3's there. So we're now here. Now we've made a swap here, so we literally just fill those in, and then we come back round, so the 1 goes down, and we're here. So now we're at the 3 v the 4. Okay, well 3 and 4 don't swap, so the 3 comes down, and then we move to here. So we're now at the 4. 4v2. Now we know that 2 is less than 4, so the 2 comes across, and the 4 comes across to there. Okay, so we're now there, and then the 5 just comes down. Okay, so if you look at this now, this means that we've got 1, 2, 3, 4, 5, okay, and then the final pass, because that would be technically the end of the second pass, wouldn't it? Here. So we would come back round to here, and we'd go again, and you'd end up with the 1 and the 3 wouldn't swap, would they? But the 3 and the 2 would swap to give us this. Okay, and your 5 marks would be 1, 2, 3, 4, 5, correct. Okay, so sorting algorithm. Let's talk about the bubble sort. Okay, the bubble sort's advantages are: it's a simple algorithm that can be implemented by a computer. It doesn't use much memory because it's literally comparing 2 pieces of data to each other at one time. Okay, it's very efficient for small lists. So on this list here, look, to check if it was in order, it'd be no swap, no swap, no swap, no swap. Because basically a bubble sort knows it's finished when no swaps take place on a particular pass. So this one, literally, it would have no swaps at all, so it knows it's in order. Okay, disadvantage, it's not very good for large lists because obviously it compares each item against the one next to it continually over a number of passes until it's in order. And it would do this for a long time, particularly with thousands or millions of items within the list. It would take a very, very long time. So it wouldn't be very efficient, it'd be slow, okay, for large lists. Thank you for watching. I hope you've enjoyed that and I hope it's helped.